So here comes our strategy for solving polynomial inequalities. First, you have to set it to 0. So you're going to have your polynomial, and you're going to have whatever inequality symbol you have, and then 0 on the right. Then you're going to find the boundary points. Boundary points are when your polynomial, let me give it a name, p of x, that's when it actually equals 0. Now, you may include those points or you may not include the points. Then you're going to draw a number line. And you're going to place your boundary points on that number line. And, they might be anywhere on the number line. They could be to the left of 0, the right of 0, one on each side. There's going to be boundary points. And there could be more than 2. If you're going to include the boundary point, you're going to use a solid line. So that's like a square bracket. And then if you're not using the boundary point, then that's going to be a dotted line, like a parenthesis. Okay? All right, so solid we include, dotted we don't include. Then you pick a test point in each section, and you try it. If it works, then great, it's part of the solution. If it doesn't work, then it's not part of the solution, okay? And then finally, you're going to take those sections that work and write it in interval notation. Now this will make more sense as we go through it. That's an overview for the strategy, okay? All right, so it says solve and graph the solution set on a real number line. So here's our polynomial, 2x squared plus x, and that's going to be minus 15. I'm going to put the 15 on the other side, is greater than 0. I have to do that. I have to have 0 on one of the two sides, and I would like to have it on the right-hand side. Okay, I need to factor this polynomial. I'm going to go through the AC method just as a quick review. So I need two numbers that multiply to be negative 30 and add to be 1. And that's going to be 6 and negative 5. I know the factoring, we really haven't had a lot of time to spend with it, and it takes a while to get good at factoring, but hopefully you're like, oh, I remember some factoring like this. Or you could use a trial and error method, that works too. And I'm just kind of doing this quickly, but x plus 3 and 2x minus 5 are going to be how that factors. Okay, now we want to know the boundary points. So when does x plus 3 equal 0? And when does 2x minus 5 equal 0? When does each factor equal 0? So my boundary points are going to be at negative 3 and 5 halves. Okay, so now here comes my number line that I'm going to draw. I always like to put 0 on the number line, and then negative 3 somewhere over there, and 5 halves, which is the same thing as 2.5, right? Okay, so let's say that's 3, 1, 2, 2.5, kind of somewhere in there. Okay, now, are we going to be including these? Do we want solid or dotted lines? Well, we're not using where it equals 0, so they'll be dotted. If it had had the equal to, we would have used solid lines. But no, we don't want to know actually where it equals negative 3. Well, we want to know where it equals negative 3, but it's not part of the solution set. Okay. Whew. All right, so we got the number line, we got the boundary points, we've got dotted lines. It's going good. Now we have to pick test points. So this takes a little bit of time. But I'm picking any number in this section, any number that's less than negative 3. And I had a really creative class the other day. They were saying all kinds of numbers that were less than negative 3. Most people just say negative 4. But you could pick negative 10 if you wanted to. Okay, but there you go. Now, I'm going to take this factored polynomial, the way I have it written there. You don't have to. You could use the original as well. But you do want to keep it set to 0. Okay. Then I just plug in negative 4 and I see what happens. 2 times negative 4 there, minus 5. And it turns out, either I'm going to get a true statement or a false statement. And it turns out it's really based all on signs. Here I'm going to get a negative 1. And here I'm going to have negative 8 times negative 5, or I'm sorry, negative 8 minus 5, which is what, negative 13? Well, what's a negative times a negative? Positive, right? So is 13 greater than 0? Yes. So this section works. It means all the numbers that are less than -3 are going to make it true. They're all going to give you some kind of negative times a negative thing, and that's going to be greater than 0. So that's, whoops, that's the first test point, that section there. Now you got to pick a number between -3 and 2.5. You can pick any number in there. Pick 1, you could pick 0. I'll pick 0. And then I'm plugging it in to see if it works. Well, here I get 3, and here I get -5. That's a -15. Is that greater than 0? No. You can put yes or no or smiley face or frowny face and whatever you like. But no, this section doesn't work. I'll try to stick with, this was a yes, it did work, and then a no that it didn't work. Okay. So we've got 2 of the 3 sections done. Now I just need to pick a number bigger than 2.5. Pick 3. You pick 100, but you know, why pick a big number? All right, what's 3 plus 3? And then what's 2 times 3 minus 5? So I get 6 here, and I get 1 here. Is 6 times 1 greater than 0? Yes. So yes, we're going to include that section. Okay. So you see some sections work and some sections don't work. Now, here we go to write the interval notation. I guess I could graph it first because they asked me to graph it. Actually, the graph is really there already. It's parenthesis here, and then parenthesis at the 2.5 and off that way. So what does the interval notation say? It says from -infinity to -3, union, now make sure you get the 2.5 in there, 2.5 to infinity, and it would look like that. You could have used 5 halves if you didn't want the decimal. Okay, so that's how we do these. They take a little bit of time.